Hello, this is day 4 of our 35 days of class. Today we will be learning about how to solve for functions and relations along with evaluating functions. For the steps to evaluating functions and relations is that you have to figure out your domain and range and then figure out if it's a function or not a function. This is our first example. How you would solve for this is that the first number is always your domain, and then your second number is always your range. Now, to figure out if this is a function or not, you would have to place it in this order to just write them side by side. Now, as you can see, that the domain only reaches to one number, which means that this is a function. This is our second example, and again, we will be writing the numbers, your domain and range, side by side. And now you can see that these two numbers, they're the same, so you don't need to rewrite two numbers that are the same. Now we have two ranges that are the same number, which is 4, and you don't need to write both of them. So 0 would go to 0, 1 would go to 1, 2 would go to 4, and -2 would also go to 4. This is another form that is also seen as a function. So, yeah. For our last example, we would rewrite this as the way that we did before. But this time we have two domains that are the same number, our two nines. Just like before, you don't have to rewrite our second number that is the repeating number. So I'm just going to erase one of the 9s. And now we will connect them. 1 will go to 1, 9 will go to 3, and 9 would go to -3 as well, and 0 would go to 0. This is considered not a function. Reason being because a domain can't go to one domain can't go to two different ranges, but yeah, basically a domain can go to two different ranges. That is not considered a function. Now this is your turn. Because there is no one here, I will be posting the video up later on Google Classroom, and yeah, try yourself at some functions and relations. Pause the video if you need to. Now we will be learning how to evaluate the functions. First, we would have to substitute the input, the given number of the expression for our function's variable, which is our placeholder, which is any letter, most common one being x, and then we will replace our variable with the number or expression. This will be our first example. F parentheses x equals 25 minus x2. As you can see that over here, we have f in parentheses and -3 in between those parentheses. We would substitute -3 into our x. So you're basically solving for like in a normal equation. Now, this would equal, now we would solve this by, oh wait, this is supposed to be, I wrote this wrong. This is supposed to be, yeah. I wrote the equation wrong, anyways. This is supposed to be a hanging 2. Now you would solve for -3/2. I mean, yeah, 2. And this would equal to a +9. And then you don't really need the parentheses in this case, but you can if you want to. And then 25 minus 9 would equal to 16. And in this case, this would be your answer. But say that there was a radical. There isn't a radical in this equation, but sometimes there are radicals in which this, you would have to simplify this number, and the perfect square for 16 is 4. So if it was a radical, fx would have been equal to 4 if there was a radical sign. To our second I wrote this wrong again. It's supposed to be hanging 2. Again, we will substitute -1 with our x. And this, you would, -1 times itself would be +1, take away 25, equals, and now you'll subtract -1 from 25, and you'll get 24. And that will be your answer. This is our last example. I forgot to put an F in parentheses. Whoops. All right. So we will basically do the same thing as before. X 5 will go to this 2. I mean x. And it would look like this. Then you would solve. So this would equal to 10 plus 4. And you add 10 with 4 equals to 14. And yeah, we have it. 14 would be our final answer. And now this is your true. Pause do them. I'll post answers later for your answer key. To summarize what we have learned today, we learned how to solve for functions and relations by figuring out domain and the range. If the domain goes to hello? Hi. Oh. I just recorded the entire thing. I'll redo it. Anyways, summary would be the function, if the domain goes more to the range, two different ranges, it's not a function, but if it doesn't, then it is a function. And always, if there's a number, if x equals to something, you would always substitute that number that's with x into the equation to get what f parentheses x means. Okay, so for this example, we would have to write out. So first off, the first number is your domain. And your last number is your range. So you would figure out if this is a function or not a function by writing the numbers out and then connecting them. If the domain goes to the range once, then this is considered a function. That's messy. Yeah. For the second example, we're going to do the same thing. You're going to write out everything. But as you can tell, there is two ranges of the same number. You don't have to write out the second 4 because there's already one and you don't need to duplicate it. This is in fact also considered a function because the range is only getting one. The domain can basically repeat how many the range can basically repeat as many times as the domain can connect to it. It doesn't really matter, it's still considered a function. For this one, we're going to write it out again, but this time we have 2 9s. Again, don't need to write the second 9, don't need to duplicate it. But this wouldn't be considered a function, so it's not a function because the domain connects to 2 ranges and that doesn't work out. And now it's your turn. Take some time, do it. Figure out if it's a function or not a function. I'll give you like 10 minutes or 5, I don't know. You don't understand how to do it? Okay, I'll show you first. So you figure out if the domain, what connects to what. So for example A, you would write it out like this. And then connect them. Now because the domain only connects to the range once, this is considered a function. And for example B, we're gonna do the same thing. We are going to write out the numbers. And as you can see, there are two ranges of the same number, so we don't rewrite 3 twice. 0. Now we would connect it, so 1 would go with 3. Oops. Hold on. Okay, so 1 would go with 3. The 0 here would also go with 3. 2 goes to 1, 4 goes to 2. This is also considered a function because the range can hold as many domains as it wants. It doesn't matter for that part. And then for example C, we would again write out the numbers. Wait, oh, I wrote 2 1s. There are 2 1s here. And draw. There are 2 1s here. We don't need to rewrite the 2. I mean the 1. And 1 would go to 6. 1 would also go to 9. 2 would go to 5, and 4 would go to 3. This is considered not a function because the same domain here, 1, connects to 2 ranges. So this is not a function. Do you understand? Yes, no, maybe so.
Yeah.
Okay. Now we're going to go to evaluating functions. So the steps to evaluating functions is to substitute the input, the given number of the expression, for the function's variable placeholder x or any letter. If it's like, I don't know, A, C, Z, whatever, it's a placeholder. And then you would replace your placeholder with the number or the expression. So for our first example, I wrote this one wrong by accident. The 2 is the actual expression should be 2, like that. So we have number -3. We have to replace -3 into this x. So it would look like this. And -3 would multiply with itself because of this 2. This would basically mean that, which would give you a +9. And okay. And draw 20. And you would write all these down as well. And now you don't really need these parentheses, but you can write them if you want. And then oh my god. you would subtract 9 from 25, which would give you fx equal to 16. This would be your answer. And now for this example, again, I wrote the expression wrong. It should have been that. Yeah. Oh, I forgot to mention for the last example. Well, I could do this example as well. I'm gonna do it later though. Okay, so you have negative 1. We would place -1 into our x in the expression, and -1 times -1 would equal to 1, and then write everything down. Then negative 25 take away 1 will go to 24, and then yeah, that's how you do it. But sometimes these equations have radicals, meaning it may look like this. You would basically solve the way I just did, but this last part you would have to simplify this number. But I don't have that answer right now, so I'm not gonna. Yeah, you have to simplify it, and then you will get a different. Oh my god. You would get a different number for what fx equals to, but I don't know that answer yet because I didn't solve for that. So this is our last example. I actually wrote this one correctly, except I forgot the f and the parentheses. You would do the same thing. To parentheses 5 plus 4. 2 times 5 equals 10 plus 4, and this will equal to 14x. And this would be your final answer. And now your turn. I'm going to give you a few minutes to do. Oops. No. Okay. Things have gone wrong. Hold on. Nope. No. Oh my god. Hold on.
Anything wrong?
Give me a sec. I will fix it. Hello, please work. Oh Jesus. Okay. Oh, yay, you work again. All right. Sorry. Share screen. All right. This is your turn. Take a few minutes to do it.
Done, I guess.
All right. Can you tell me your answers and I'll confirm?
First one.
Yes.
All right. 37.
Correct. Next.
Next is 5.
I don't think.
Is that an exponent or like number 2?
It's an exponent. Exponent. Sorry, exponent.
And number 3 is 7.
Yes, that's correct. So now it's time for summary. If you may tell me what you have learned.
Well, I don't know the topic of the.
You don't know, oh, it's functions and relations and
Oh yes, today we learn about functions and relationships, also with equations. Work.
okay. That so like you understand
Yeah,
everything correctly,
yeah.
right? All right. So that was basically it for class.